Hi, we are going to check out evolution of networking or networks. Evolution of networks are directly related with the generations of computation. So the computation means the way we process the information. Now, if you talk about the first era, it was the era of centralized competition. Within this particular first era, that is, I'm talking about before 1980s, we had centralized competition in terms of machine from IBM called as IBM mainframe. This IBM mainframe machine was having a centralized microprocessor and the terminals were connected to it. Users are supposed to sit on these terminals and they are supposed to work on this centralized IBM mainframe. Now there was a single microprocessor which was serving multiple terminals, ultimately multiple users. These terminals, that's why they were referred as dumb terminals. Dumb terminals means the terminals which just had input and output devices. They didn't had any processing capabilities at all. Now the era of networking started over here because if the terminal is located at a far away place, a telephone line was used to get connected to the IBM mainframe. Centralized computation means we'll be having a centralized machine, that is IBM mainframe, and we'll be having dumb terminals connected to it. Now all these dumb terminals will be working on this centralized microprocessor. Overall, we can say that these terminals doesn't have any kind of processing capabilities. So whatever the task given from the terminals were getting executed on this centralized IBM mainframe microprocessor. Now networking was still used to connect these terminals with the main IBM mainframe. So let's say if I am having a dumb terminal located at a faraway place, I can use a device called as PAD, stands for packet assembler disassembler. So this PAD was getting used and I can get connected to this centralized IBM mainframe by using this. They were using telephone lines for that, and that's how the initial networking started, that is just to connect a dumb terminal with the main IBM mainframe. But the revolution happened in 1980. IBM came out with their next product in 1980 called as PC, stands for personal computer. Now this PC was getting used as another terminal just like the previous terminals, but the previous terminals were dumb, that is they didn't have any kind of processing capabilities. Now this PC had its own microprocessor, so even though it gets disconnected from the main IBM mainframe, still this PC can work on its own. That's why it is called as PC, personal computer. That is first time in the history we got personal processing power at a local desktop. Before that it was era of dumb terminals, no processing power at the local desktop. But first time here we got processing capabilities at the local desktop. So personal computation was provided to every terminal, ultimately means every human being. So that's why it is called as PC, personal computer. Now the business owner started thinking, because if this PC can work on its own, why I should have so much amount of money to be spent on this IBM mainframe? So they started thinking that let's not purchase mainframe, and instead of that, why not just go on purchasing PCs for every user in the company? So they started purchasing only PCs and started working individually on the PCs. Now there was a need that the data amongst the PCs should be shared. That's where the first level of networking came into the picture. That is, we require connectivity to transfer the data from one PC to another PC. So in 1980, this product from IBM, that is personal computer, we call it as the game changer, was there in the market, and people started using this personal computer or PCs. They started connecting it. This we call it as second era. Now within this second era, check it out what happens. For our example, we are having two PCs over here, PC A and PC B. Now let's consider we are having some data on PC A, and this data is XLS file, that is Microsoft Excel file. And let's consider the name of the file as myfile.xls, and it's having the information of person's name, address, telephone number, etc., and so on. It's having, let's say, lakhs of records of it. And this particular file size is 10 MB, and out of that, one of the record is a record of Mr. Mandar Markade, and this record, the size of the record is hardly 10 KB. Now there is a person sitting on PCB, and this user from PCB needs the information about Mandar Markade, so he wants to get the record of Mr. Mandar Markade. Technically, let's check out what happens over here. The user from PCB is going to send a request for PCA. Now this request, ultimately it's not going to be for that record, it's going to be for myfile.xls. We know how it operates. So a request will be sent from PCB to PCA. Now PCA will be using its processing power, and it will be sending myfile.xls to PCB. So PCA grants the request and sends the file. Now how much amount of processing power will be utilized over here? As PCA sends this request on the network, so PCA is supposed to process or utilize its processing power equivalent to 10 MB, because it's sending a file of 10 MB. Now PCB again is going to collect this file. So PCB gets the file and opens it. How much amount of processing power will be utilized on PCB? Because it's collecting 10 MB and it's opening 10 MB. So 10 MB equivalent processing power will be utilized. Now I'm not going to calculate in terms of hertz or something. We are trying to get the explanation logically over here. So 10 MB equivalent processing power will be utilized on PCB. Now whether user from PCB has received or got the information of Mandar Markade? Answer is no. He had just opened the file. Now what it is supposed to do again? On PCB, user gives a find query for Mandar Markade. So 10 MB of that myfile.xls is supposed to be scanned out for the record of Mandar Markade. Again, I'll be saying that PCB will be utilizing 10 MB equivalent processing power, and then he gets the record of Mr. Mandar Markade. So overall, if you look out, PCB has requested. During the request, some minor processing power will be utilized. PCA has granted the request, send the entire 10 MB. Network utilization is also equivalent to 10 MB. Now PCB has received the file, processed it, that is opened it, and then it's going to scan the file for the record of Mr. Mandar Markade. So 10 MB while sending, 10 MB equivalent processing power while receiving and opening it, and 10 MB equivalent processing power while getting the record out of that of Mr. Mandar Markade. So together, that's why we call this as decentralized computation, because processing power utilized was 3 times more processing power. Overall, this was second era. We call it as decentralized computation. The first one was centralized computation, IBM mainframe and the terminals. The second one is a decentralized computation, that is the PCs, that is personal computers connected together. Business owners were very happy initially because they had machines for individual users, and they were able to save the costs as they were not supposed to purchase expensive IBM mainframe machines. But soon they found that the data is decentralized, so we require a network to connect all these pieces together. And second very important point was the processing power requirement started increasing because the data was decentralized. And as I already explained with the previous example, we require more and more processing capabilities at the PCs. Now let's talk about third era. First one, centralized competition, that is with IBM mainframe. Second one, decentralized competition, with that is PCs connected across with the network. Third era, it's called as client server. Now, client server generation, it has picked up towards the late 90s. Now, within the client server generation, what we have is a centralized machine. This machine is called as server. All the data resides on the server. Server typically hosts the databases like SQL or Oracle, just for the example. But on a logical level, the server is called as backend. Now, on the user side, we have front end. So, if you want to talk about the machines on which the users are working, that is typically referred as clients. On that client, the software that we have is called as front end software. Now let's carry out our previous example ahead. In the previous example, we have seen that there was an Excel file which holds the database of 10 MB. So that's why in this example, let's consider that we are having a SQL or Oracle database of 10 MB only. The database is the same database, that is person's name, address, telephone number, etc. etc. Now talking about the client, on the client, front-end software is already installed. Now what is this front-end software? If you go to any bank, you can see that their desktops are having their customized softwares. These customized softwares are nothing but the front ends for the database server or the other servers. Now this particular front end software, it has the find query within itself. Unlike the previous case, we asked for the file and the file was entirely transferred. Here this front end software will be having all the options which are going to deal with the records. So let's consider the example. Process number 1, first step, client sends a request. Now in this case, the request will be directly for Mandar Markade, because as I told you, in the front end software will be having a find tab. So client sends a request. Request is for Mandar Markade, but only request will be sent to the server. So the request goes to the server. Server accepts the request. And now server scans it locally for the Mandar Markade's record. So locally I will consider that it scans 10 MB of data which is already there on the server. Now this 10 MB of data, after scanning it, what it gets is a record of Mandar Markade. Now server sends that record back to the client. So that particular record goes to the client. Remember, the transfer is not the entire 10 MB database, it's just the record, that is final answer, which is hardly of 10 KB. So when this record goes to the client, client will show that record to the user, and that's it. Now what's the advantage within this system? Check it out. Server will require a good hardware, definitely, for sure. Server is going to serve all the clients, so it must have good hardware, plus it's processing locally, so that's why it should have a good hardware. But server will be always only one, but the clients behind that on which the users are working will be thousands of clients. So if you talk about the client systems can have minimum hardware and company can save a huge cost on this. Data remains centralized on the server, that's an additional benefit that we get. So whatever you want to check it out, you can check it on server all the times. Clients positions can be changed. Users can sit at different locations, that's possible. And finally what we get is a benefit that only small records are being transferred, so the network utilization will be on the minimum side. Bandwidth utilization will be on the minimum side. We have seen the third era, that is client server technology. Now client server technology altogether, it was great. One centralized server with the entire database, remaining clients getting the database. But for the non-IT organizations, they are supposed to maintain this client server technology. They are supposed to develop the softwares. They were supposed to maintain the infrastructure, which was a bit difficult for the non-IT organizations. Just imagine a company which is into tire manufacturing, or maybe which is there in the food product manufacturing. Instead of doing their regular work, what they are supposed to focus is on this client server technology and the infrastructure maintenance, which was a bit difficult. And this has led to the next generation, which is the current generation. I call it as fourth era. and that is cloud computing. With the third generation, we are facing many problems. Servers were locally hosted. So if a company is having multiple branches, you are supposed to set up multiple servers. Next, non-IT organizations, as I said, they were facing problem to maintain this entire infrastructure. You are supposed to manage and maintain, so you are supposed to appoint the staff as well, the staff for the infrastructure maintenance and the staff for the software skill sets. Now if you talk about cloud computing, what we are currently watching out, you don't have to manage or maintain any servers. What you are supposed to do is just use the service. So instead of maintaining the servers, now you can rent a service. Again, all these servers are hosted in the cloud. Cloud means on the internet. So flexibility is there. You can work from anywhere. Most of you are using the Gmail services. What is Gmail? Actually, it's an email service. Previously, companies were hosting their own mail servers, and people used to have their own email IDs which are hosted on the locally hosted mail servers. But now instead of that, we are getting this Gmail service from the Google where everyone is having email account, and this email account can be operated from anywhere because the server is there on the cloud. That's the best example of cloud computing that I can give it to you. Clients can be any devices, like we have seen there are Gmail clients on the smartphones also, so you can check out your mails on the smartphones also. You don't have to buy a laptop or a PC for that. Nowadays it has gone up to such a level that even you can use your smart TVs as a clients. And moving ahead, this is just I'm talking about some services. So moving ahead, you can have software as a service in this cloud computing. Previously, we used to install Microsoft Office. Everyone is aware with that. Now this Microsoft Office is having lots of versions. Every time the new version comes, you are supposed to throw away the previous version and install a new version. Then you are supposed to check out your system compatibility, whether your hardware is compatible with the latest Microsoft Office version or not. Now Microsoft has given you Office 365. You don't have to maintain any software on your device. Directly log on to the Microsoft's website and you can start working with Word, Excel and PowerPoint. So this is the next generation, and that is cloud computing. Now if you talk about first generation, that is centralized computation, second generation, that is decentralized computation, third generation, that is client server, or the fourth era that we are having, that is cloud computing. In all these generations, what is common? Networks. This is the only common thing that we have in all these generations. So that's the importance of the networking. Networking is there, that's why we are able to develop such a system where you need to have just a smartphone in your hand and you can do anything, right from your banking transactions up to working on your office work. Thank you.